I'm Erika Miller,
I'm Acquaye.
And I'm Mark Kurtz.
and we are RC Glider 1. So our project was to design a radio-controlled scaled model glider with true morphing wings, which means that the shape changing controls how the glider moves, whether it elevates or changes direction. And one of our stipulations was instead of ailerons, the wing has to change shape to control it. So we had 4 original concepts to choose from, and we chose this selection because of its lightweight material. The glider can't be too heavy. The skin around the wings has to be an elastic material, and the airfoil cross sections inside the wings needed to be strong and also lightweight enough, as well as we needed a pretty simple manufacturing process.
So for the final prototype construction, as we can see over on the left image, it's made up of these cross sections that go along this aluminum bar, which we call a torsion bar. That torsion bar is controlled by servos in the main body that twists it back and forth. The cross sections are free to rotate about that torsion bar except for the very last one. The very last one is connected to the torsion bar, so as the servos twist it, it's actually twisting that outside cross section. So that outside cross section then controls the inner cross sections through our elastic skin. The elastic skin is made out of an elastic fabric at the base, and then a plastic layer, and then another elastic fabric layer. The 2 layers of elastic fabric keep the plastic into the airfoil shapes, and then the plastic keeps it impermeable to the air. And you can see over on the right over here, this is our final prototype before we flew it. So we're going to go through a couple of our videos of our final demonstration. First one is a wing demo. This will bring that up. So this is just showing our wings working and morphing. As we can see, we have control, variable control over both wings, and they morph throughout the entire wing. And we'll bring up the next video. This is our initial prototype flight. Didn't go too well, but luckily we made a lot of improvement over our next 2 flights. So we'll see this one go, and it takes off, and we'll replay this one again because whenever we launched it, it was a really windy day, and the wind caught it as it went up and threw it back on itself. So it was backward, or it was upside down, and we were able to get it to right itself. But then unfortunately it crashed into the only concrete area on Art Hill. So you can see it go up, folds back on itself, and then we can get it to right itself, but it's too late. And then finally we can see our last prototype flight, which went a little bit better. You'll see it going. So we get it going, and the prop gets going. We launch it, and we can see that we have pretty good maneuverability, and then it eventually ends up hitting the ground, and that's a problem with one of our designs that Francis is going to go over.
So for future work, one of the main concerns that arose as we were constructing the RC glider was the overall weight of the plane. As a result, if we were to construct another prototype of the glider, we would like to decrease the weight by getting smaller servo motors that would still be able to provide the necessary torque. We'd also choose a lighter torsion bar, possibly made of fiberglass. And for better pitch control, we would add rear ailerons, as we already have roll control. We'd also like to get more flight data by testing the glider a few more times, and in doing so, we'd also like to check the weather forecast beforehand. And we might also add landing gear to the glider. Thank you.